Okay, in this video, we're going to start solving some logarithmic equations. And the first type that we're going to be solving is of the form log equals log, which is very similar to something we've already done. And the reason this is very similar is because a logarithm and an exponent is basically the same thing. So if you remember back when we solved the equations 2 to the x equals 2 to the 6 where the bases were the same, and we were able to just forget about them and solve them that way, this is the same thing, except for you have a logarithm equal to logarithm. Here's your steps. Step number 1, condense your logarithms. Use your rules of logs if needed. Then you're going to use this one-to-one property, which we just talked about. If a log base b of m equals log base of b of n, then we know that we can just drop the logarithms, and we know that m is equal to n. And then we're going to solve and check for extraneous solutions. Reminder, you can't take the logs of negatives and that sort of thing. We have log base 5 of stuff equals log base 5 of stuff. Forget about the logarithms and simply set 5x plus 9 equal to 6x and solve. Move your 5x's to the other side by subtracting, and you get that x is equal to 9. And you can plug those in, and you will get the log of 54 equals log of 54, which does check out. Number 2, again, we're going to forget about our logarithms and simply set 1 minus 4n equal to 2n plus 43. Let's move our minus 4n by adding and move your 43 by subtracting. That gives you negative 42 is equal to 6n. So therefore, that means that n would be negative 7. Plugging that into my original function gives me 1 plus 28, which is 29, and 43 minus 14, which is log base 2 of 29 as well, and it does check out. Number 3, forget about the logarithms. Set the other stuff equal to each other. I'm going to move my minus 3w by adding 3w, and I get that 6 is equal to w. That was pretty simple. I'm done. Let's plug that in to check. 6 minus 18, that's going to be a negative 12 equals negative 12. Got a problem. A lot of people say, oh, they're equal then. You cannot take the logarithm of a negative value, so anything that would make that negative, we have to throw out. So therefore, this would be a no solution equation. Number 4. Now here, notice step number 1 is to condense the logarithms. If you have two different logarithms on the same side, this is why we learn the rules of logs. A log plus a log can be condensed into a single log by multiplying these together. That'd be 4y plus 20 equals the log of 72. So the first step, condense it into single logarithms if possible. And then, again, forget about the logarithm. 4y plus 20 equals 72. Subtract the 20 gives you 4y is 52, so y must be 13. Plug it into your original. That'd be the log of 18 plus the log of 4 equals log of 72, and you can do that. 18 times 4 does give you that 72 when you plug it in to check, or you can plug it in here to check as well. Number 5. Again, let's condense this. Let's get rid of that times 3 by raising it, bringing it up to the exponent. And that gives you log base 7 of 4 to the third, which is 64, equals log base 7 of 4a minus 8. Since you have the same bases, forget about them and set the 64 equal to the 4a minus 8. Move the 8 over by adding. Gives you 72 as 4a, so a must be 18. Let's plug it in and check it. You can do 72 minus 8 is 64. So you have 3 times log of base 7 of 4 equals log base 7 of 64, which does check out. Okay, number 6. Again, condense your logarithms to do a log minus log. You're going to write that as log base 4 of 68 over 4, which we know that 68 divided by 4, if you want to just go ahead and divide that, is 17 equals log base 4 of 3n plus 11. Log equal log, 17 equals 3n plus 11. Again, you can just cancel your logs out. Subtract the 11 gives you 6 is equal to 3n, so n would have to be 2. Again, go back to your original and just make sure when you plug it in, the biggest thing is just make sure when you plug it in, you don't have the log of a negative. When you plug it in here, it gives you 6 plus 17, and that does check out. You don't have to worry about domain restrictions there. Next up, move the 1/2 up to an exponent, and you have the log base 6, 25 to the 1/2. If you don't remember, a 1/2 power is the same thing as a square root. So that'd be log base 6 of 5 equals log base 6 of 23 minus 4w. Bases are the same, so therefore we can get rid of the logarithms. 5 equals 23 minus 4w. Let's move our 23 over by subtracting. Gives me negative 18 equals negative 4w. So w would be 4.5. Plugging that back in, right here would be the only place that you might have trouble, but 23 minus 4.5, or 4 times 4.5 would be 23 minus 18, 23, yes, minus 18, which is 5, so that does check out okay. Next up, you have a couple of things to clean up over here. Let's move our 2 to the exponent. So now you have log base 3 of 2p minus 5 is equal to 6 to the second, that would be 36. So you now have log base 3 of 36 over 4 because of the subtraction. We know that we can write 36 over 4 as 9. So you have log base 3's on both sides, so we can get rid of the log base 3's and simply set 2p minus 5 equal to 9. Add the 5 divided by 2 gives you p is 7. Go back and make sure plugging in 7 will not give you any restricted x values, or in this case p values, and it gives you a 9, so you are perfectly okay. Okay, next up, now we're dealing with, more of the same. Log base 4's equal, so therefore you have m squared, you can get rid of them, is equal to 18 minus 7m. You have quadratic, so therefore let's move everything to the same side. Plus 7m minus 18 equals 0. 2 sets of parentheses. M times m is m squared, adds, multiplies positive 9, and a negative 2, so 2 possible answers of negative 9 or a 2. Would either one of them give me issues when I plug them in? This would be when I plug in negative 9, it's 81, so I'm fine there. When I plug in negative 9 here, you get 18 plus 63, which is also 81. So negative 9 is fine. When I plug in 2, it gives you a 4 here. Here it gives you 18 minus 14, which is also 4, so therefore we are okay with both. Condensing, we have addition, so we're going to combine those two by multiplication. That'd be log base 10 of 2k squared equals log base 10 of k squared plus 16. Forget about the logarithms, and you now have this. Move the k squared over, gives you 1k squared is equal to 16, and even though it's quadratic, we can solve this with square roots. K will equal plus and minus when you take the square root. The square root of 16, which is 4. Let's try them both out. When you square a negative 4 here, it gives you 16. When you square a negative 4 here, it gives you 16 plus 16, which is 32. That's fine. Same thing with positive 4. They're both going to work out okay. Now, we're going to work with what happens when you have a logarithm equal to a number. We're going to condense and isolate again, combine it into a single. We're going to rewrite our equation in exponential form, and we're just going to solve that and check for extraneous solutions. Like here, isolate your logarithm, and then simply change forms. 2 raised to the 6th power, this is exponential form, is equal to x minus 4, and you're pretty much done. 2 to the 6th power, that's going to be 2, 4, 8, 16, 32, 64 is equal to x minus 4. Move your 4 over and it gives you x is 68. Check for extraneous solutions. Make sure that you're not taking the log of a negative and you're okay. Here I'm going to isolate the log first, so let's move a 7 over, and that gives me log base 3 of 4x plus 8 is equal to negative 3 and 7 is 4. Let's rewrite it in exponential form now. We isolate it, rewrite it, so that'd be 3 to the 4th power is equal to 4x plus 8. And if you know what the power is, once you raise 3 to the 4th, if you'd like to just write that answer, that'd be fine as well. Subtract 8 gives you 73 equals 4x. So therefore, x will be 73 over 4. You can leave it like that, or you can reduce it either way. And plugging that in, you will be fine. Number 13. Condense these. You condense addition of logs with multiplication. So I've got to multiply this times this. So that'd be 2x times x minus 5. is equal to 2. That would be the log of, let's clean that up, that'd be 2x squared minus 10x is equal to 2. Rewrite it in exponential form. This is a base 10, so that's 10 to the second, which is 100 equals 2x squared minus 10x. Now, I noticed something already. All three of these are divisible by 2. Before I move anything, let's reduce this. It gets 50 equals x squared minus 5x. Always reduce your equations. Now, since it is quadratic, let's move everything to the same side. Subtract 50 and you get equal to 0. Now let's factor what we're left with. Two sets of parentheses. Adds, multiplies would be a negative 10 and a positive 5. So my two solutions here would be either an x equals 10 or an x equals negative 5. Let's check for extraneous solutions. Plugging into my original, would either one of them give me a problem? Plugging in a 10 gives me a 20 and a 5. And you can check that and that will be perfectly fine. However, when you go to plug in the negative 5, you cannot take the log of a negative. So plugging in a negative 5 here gives you the log of negative 10, which you do have to throw out. Cannot take the log of a negative. Next problem. Again, let's condense the left side. The squared, we can move up to an exponent. And you have a log minus a log, so that'd be the log of x squared over 4 is equal to 2. Next step, you're going to rewrite it. This will be 10 to the second power, which is 100, is equal to x squared over 4. To get rid of the 4, we multiply. That is 400 is equal to x squared. So therefore, x, to get rid of the square, we're going to square root. That's going to be plus or minus the square root of 400, which is 20. And again, ask yourself, does either one of those give you any problems? And one of them will. You cannot take the log of a negative, so plugging in 20 is fine, but plugging in that negative 20 is going to give you right here the log of negative 20, which you cannot do. So we're going to throw away the negative and just keep x equals 20. Okay, number 15. Again, we have addition of logs, so we're going to condense it down by writing it as log base 6 of, we got to multiply these. That'd be x squared plus 9x is equal to 2. We're now simply going to change forms. 6 to the second is equal to x squared plus 9x. Since this is quadratic and you're not missing the b term, let's move everything to the same side by subtracting 36. Factor, two sets of parentheses, adds, multiplies will be xx, a positive 12 and a negative 3. We'll give you that. So therefore, my two solutions would be a negative 12 and a positive 3. Let's check for extraneous. Plugging in a negative 12 right here already, you cannot take the log of a negative, so we're going to have to throw it out. Plugging in a 3 gives you log of 12 plus log of 3, which is going to be perfectly fine. Number 16. A log plus a log, again, we're going to combine those by multiplication. That'd be x squared minus 3x is equal to 1. Rewrite it as 10 to the first power, or 10 is equal to x squared minus 3x. Let's move everything to the same side since it's quadratic. So minus 10, factor, two sets of parentheses, x and an x, that's a negative 5 and a positive 2. So we have two solutions of either 5 or a negative 2. You cannot take the log of a negative, so right here, x cannot be a negative value. However, when you plug in 5, 5 minus 3 is 2, and that would be log of 5. So log of 2 plus log of 5 would be log of 10, which does equal 1, so therefore that one does check out.